Good afternoon, everyone, and thank you for showing up to this panel discussion today. It's a pleasure to be here, and I was really happy when Haima asked if I'd moderate the panel on behalf of, WISIS, Western Canada affiliate. So business leaders are talking about it. Educators seem to be paralyzed by it. Even artists like Drake are expressing frustration with it. I'm talking about AI, right? And then there's quantum computing. We've been talking about it for the last decade or two. It's supposed to be impending. It's supposed to blow up all of our encryption and, allow us to also make stronger ones. It's supposed to be, the dawn of a new era. And both of these technologies have an impact on cybersecurity. And so our aim today is to really get a general understanding of what we talk about when we talk about AI, when we talk about generative AI, when we talk about quantum computing, and specifically how it affects or how it potentially will affect cybersecurity. All right, so that's what we're gonna do. We have limited time, so we're gonna try to be as efficient as possible. We're gonna break this up into 3 sections. So we'll have introductions, and I'll introduce you to our wonderful panelists, and then we'll go into a series of questions, and then finally, we'll have some time for you to be involved. So if you've got some questions, start thinking about it, jot it down. We'll try to get to it at the end. Before I get into introductions, though, I wanted to mention that Celia Wanderley was supposed to be with us today, but she had an emergency in her family on the weekend, and so she couldn't make it. So we just send our thoughts out to her and hope that she'll be able to join us maybe at a future BSides Edmonton panel. All right, so are we ready? Yes. All right, so I'm gonna just pass out these little cards to my panelists here. And for the audience, I would just like you to turn to your neighbor. All right, and if you're not sitting close to anyone, come on, get cozy. All right, don't be scared. And when I say the word AI, artificial intelligence, just tell your neighbor, what comes to your mind? What's one word that comes to your mind? Okay, so do that, and I'll have the panelists, they're writing their words, and they'll share them with us in a little bit. It's okay, we can have fun with it. All right, so I hope you have your one word for AI. Don't shout it out yet. Now I'm gonna say quantum computing. What comes to mind? Also hold your word. All right, so anyone wanting to share? When I say AI, what comes to mind? One word? Tile. Robots, all right. Love it, unemployment. Chat GPT, I knew it, right? Opportunity, there we go. Terminator. Transforming. Oh, 2 words, okay. Hello. All right, what about okay, one more. Skynet. Oh, I know we're gonna go Terminator. All right, what about quantum computing? Physical. Disaster. Prashant, get ready. Anything else for quantum computing? Oh, I like how you think. All right, so, when we listen to those words around the rooms, we've got the enthusiasts, and then we have, just a little bit more trepidation, right? Some of us are a little bit I don't know if I trust this. So I want to introduce our panelists today, all right? And I'm going to just start with who's closest to me, right? Let me get my notes here. I'm sitting right next to Pooja Shah. She is a second-year graduate student at Concordia University of Edmonton, and she's pursuing her master's degree in Information System Security Management. She specializes in the administration of endpoint security and data loss prevention tools, leading the global data at rest function at Visa, Inc. She has an unwavering passion for information security, and that fuels her commitment to staying abreast of the latest developments in the field, ensuring that she can make substantial contributions towards fostering secure digital environments. Pooja, welcome to the stage. And why don't you just tell us a little bit about why you chose the words that you did. Just, you could, share, hold your card up, tell us what's on your mind.
Thank you. So the word that I chose for artificial intelligence is future. It definitely seems like a future. So, and the word that I chose for quantum computing, it's revolutionary. It's going to make a lot of changes in so many different fields. So, yeah.
Thanks, Pooja. I'm sure that that resonates with a lot of you. All right, next to Pooja is Prashant. No stranger to the B-side stage. I know that he had a talk yesterday. I think he has a talk every year, maybe several, right? We're very happy to have you, Prashant. He has a bachelor's and master's in IT and 14 years of IT experience here in Canada across various industry verticals. He works as a senior cybersecurity advisor for a Fortune 500 and has numerous research papers in the field of quantum computing, a YouTube channel, so check it out. He calls himself a geek with a purpose. He likes to support budding talent, share his experience, and continue to progress the cybersecurity discipline in industry, academia, and research. Prashant, what did you write on your card, and tell us why?
Okay, Nickkisha, before I do that, just to plug on Haima, she said it's a women's conference. They say behind every successful man, there is a woman. I must say, before every successful women group, there's a couple of men on stage here. Just men. So, so I put artificial is not real. I know it's not just one word, but I think there's a stream to that. On the quantum side, I put physics marries computer science.
Awesome. Thanks, Prashant. All right, and then Mashhood Ahmed. Mashhood Ahmed embarked on his research journey into the realm of AI and its profound impact on technology, project management, and business in 2017. Over the years, he shared his insights on these compelling subjects at various global events, such as closing keynote at the North Carolina PMI conference just this August. With an impressive career spanning 18 years, he runs a consulting practice and also teaches project management at Grant McEwen University. Currently, he serves as an AI advisor to project management software, to a project management software startup. He is also a member of the ISACA Edmonton chapter board. Mashhood, welcome to the panel.
Thank you, Nickkisha. So, talking about AI, what I put is I'm not worried about AI, I'm worried about natural stupidity. Because AI is artificial intelligence and it has to compete with natural stupidity. We have seen in some of the talks how you can have all sort of security, but if you do not make sure your people are aware about the security practice, they could become your weakest point. And that would be the challenge in future. Regarding quantum computing, I just put faster computers. That's sound to me. Thank you.
Thanks, Mashhood. All right, so now that we've got the introductions out of the way, and we have an idea of what we're thinking in terms of these emerging technologies, why don't we get a little bit closer to it? I don't know if anyone's wondering, but I would like a formal definition of really what is AI? Right? There's so much in the media. Everyone's talking about it. You hear about AI, you hear artificial general intelligence, you hear generative AI, you hear artificial superintelligence. So Mashhood, do you want to just take us there? What are we actually talking about when we talk about AI?
So AI, to me, the definition is ability for computers to mimic human tasks or behavior. So any computer program that can mimic human behavior, that includes pattern recognitions, decision-making, and analysis. That is AI. That's a general definition. Then within that, we have machine learning, deep learning, artificial general intelligence. That typically refers to a time when everything will be automated by AI completely, right? And that could be, some people and some gurus say that would be the end of humanity. And I don't think we'll get there ever. I think we will have lots of control that will be put on AI. For example, one of the speakers this morning was talking about he tried to do certain things on ChatGPT and now he cannot do it because AI tells him there are some control that you cannot do these types of questions. So, and then we have generative AI, which means an AI that can generate the content. So content like written content that we have experienced using ChatGPT, pictures, voice, videos, any type of generative content that we can generate using AI, that's under artificial general intelligence.
Thanks, Mashhood. Pooja, did you want to add anything to that?
Sure. This was very good description of AI, but something that I can add about AI is it's like a neural network. So it's continuously learning. And the one way that I would like to see AI is we are in the very beginning phase of AI revolution. So whatever inputs we are putting in the AI network, it has some kind of response as well. It's like, we are kind of creating a future together. So yeah, we just have to make sure that we understand AI's capabilities as well as its limitations too.
Thanks, Pooja. So we're going to get into some of those limitations and some of those capabilities. But before we do that, why don't we also start with a definition of quantum computing?
Okay, thanks, Nickkisha. Quantum computing. Well, it's quantum plus computing, right? So, I in fact got a little model here. I thought, how to speak about quantum computing from an actual artifact standpoint. So what you see here is actually a processor, an Intel processor. What is quantum computing? End of the day is our future. Let's deal with it. It is coming. Moore's law. I don't know how many of you know what Moore's law is, right? Every 18 months, your processor's density goes double, or your transistor capacity goes double. And at some point of time, your transistors, which are actually what makes this, right? The switches, zeros and ones, the 5 volts and the 0 volts on a processor, go to a point where they will be of the dimension of an atom, or a proton, or a neutron, if anybody of here has been a physics student in their life. When it comes to that, classical physics of Newton doesn't subside, and it is the quantum mechanics, the quantum physics which takes over, which behooves common sense. If you ever go there, one of the greatest scientists of quantum mechanics said, if you're not confused by it, you have never understood it. So, but we are there, and we can probably talk later on our panel on what some of the applications are. But quantum computing is inevitable. Let's just get on with it. Let's learn what it is and where we are going with it. Thank you.
All right. So, Prashant, could you tell us, how does it differ from classical computing?
Good question.
Yeah.
So I got a ball here. Well, if I throw a ball and it comes down, what is this? This is gravity, right? Gravity goes up to down. When you throw this ball and it comes down, it could come in a million different ways or infinite ways. Those are quantum mechanical paths. So in the world of proton and molecules, those quantum mechanical paths are unknown. They're all physics. They're all mathematics. And as long as you observe it, that mathematics actually becomes an actual flow. So that's the difference between classical computing, what we are used to, the phones, the computers. This is the classical computer in our hands. But at some point in time, it will come to a point where you cannot see how it's being processed, but it's being processed behind the scenes. And the only way you will actually identify it is by observing it, and you figure out, oh, it's a 0 or a 1. But between its input and its output, it's infinite number of ways how you can deal with it. What you see here is actually in the quantum computing world, they call it a block sphere. All the points on this sphere are actually points of information you can code on it. That's called qubits, quantum bits. And right now, we just have a 1 or a 0 in classical computers. So I'll stop there. I mean, we can keep talking a lot. But the fundamental difference is a 1 or a 0 versus infinite points on a ball, which could be the information coded on a qubit you can process. And that's what faster means. Thank you.
Are you sufficiently confused? Well, he said, right? He said, if we're not confused, we don't understand what we're talking about. No, so it's good. I think I took away from that, Prashant, that classical computing, we're talking zeros and ones, it's very binary, right? When we go to qubits in the quantum realm, it's all over the place. Yeah?
That's absolutely correct. Yeah, it's all probabilities, it's all mathematics, but there is a point where that world meets the world of our actual reality. And those are the computers we are building right now. But you're absolutely right.
Okay, so I want to follow up on something you said, and then we'll also follow up on it from the AI perspective as well. You said quantum computing is here, it's inevitable, we can't deny it. And I want to challenge it and say, is it really here? Can we talk about what applications there are currently of quantum computing?
Absolutely, absolutely. Go check it out. Go Google it. Quantum cryptography, BB84 protocol, one of my previous professors in Montreal, so we talk about quantum computers. Let me be very honest with you. It's not just about computers, it's about communication also. And quantum communication is a proven field. Go check out D-Wave. Go check out Magic Q Technologies. Go check out Google. Go check out Microsoft. They actually have quantum simulation. Go check out IBM. They have an IBM ecosystem on quantum computing with actual real quantum hardware computing to a certain extent. IBM broke the RSA algorithm, which we all say is foolproof for classical computers, with the prime numbers, 5 into 3, 15, 15 broken back into 5 and 3, which are prime numbers. So what's it called, a Shard's algorithm. They actually did that on a carbon molecule, and they proved it. The physics of sending data up to the satellites and down, using quantum computing in credit card fraud detection, in stock market analysis, optimization problems with ships, optimization problems with sending oil from one point to another. In fact, I work for Enbridge. The Fortune 500 company is actually Enbridge. Optimization problem on the traffic, folks going through the airports. The optimization problem on Alberta Energy Regulator. There's a company which in fact did use AER's data to forecast energy prices in Alberta using quantum computing algorithms, simulating it in quantum hardware. So it's not something out there. It is happening as we speak. Optimization, cybersecurity, credit card fraud detection, for stock market analysis, as I said, ships, and this is a very big optimization problem. So simulation, optimization, security, forecasting, fraud detection are actual applications where quantum algorithms are being used.
Okay, so you say quantum algorithms are being used. Are we using quantum computers to run those algorithms, or are we using classical computers to run those quantum algorithms?
Good question. So good, thank you, Nickkisha. So right now, don't quote me exactly, IBM experts can probably speak to that. We have a 100-qubit quantum computer which has seen the light of the world. To answer your question, we don't have a mass-scale quantum computer run quantum algorithms, so they simulate, for the most part, quantum algorithms using Python, using Q#, using certain languages on their platforms, Azure, Google, IBM, and they use that on, right now, they're using classical hardware, to be honest, but they simulate it and abstract it so that they can still get the actual results of what quantum algorithms can do.
All right.
That way, they're able to solve a bunch of problems at this point in time. Yeah. One quick one, just to add on a plug to that. Random number generators. How many of us know random number generators are so important in computer science? We actually don't have randomness in our world if it is classical in nature, because you can predict from point A to point B what it is. In the quantum world, it is pure randomness. Google is actually building a quantum random number generator. Imagine the possibilities which will come with that. Thank you.
Thanks, Prashant. All right, what about on the AI front? Now, I don't think, or maybe there are persons in the room that would actually say, we're not very far along in AI, but I'm not sure. We'll check later, right? What do you think, Mashhood? How far along are we, and what's the future looking like in terms of?
So I think with AI, it's here right now. All of us have experience and used ChatGPT to some extent, right? Some of us have done some advanced computation and using AI, generative AI, for our benefit. So it is here. It is not something that will happen in the future. It is happening right now. And now we have seen all the computation comes in. So Google Bard is there, Meta Llama is there, Cloudy 2 is there, and there are a bunch of other AI tools out there. And then there are specialized application of machine learning in special industries, for example, in healthcare, in radiology, that are coming there. So AI is real. It is here. It is something that all of us have experienced and will continue to experience, and it will only get better. Thank you.
All right, so I want us to play a little game, all right? I'm going to pass you these cards. All right, and I'm going to make a statement, all right? And then they're going to show red or green to indicate whether they agree or disagree with what I'm saying, okay? And then we'll get into the why. All right, so ChatGPT and AI are gonna take cybersecurity jobs. Oh, wow, we have consensus. All right, so Pooja, do you wanna start us out on this one? You're saying no, they're not gonna take jobs. Let's talk about why.
So I think AI will have an impact on all of these actors, and one of the biggest would be cybersecurity, because we can see that offensive attacks will increase, and with that, of course, we'll need defensive people on defensive side as well. So, like Mashhood also said, there will be a big gap in the awareness. So I can say that there will be a shift in the type of job that we have to do, but there will be a lot of demand for cybersecurity. That's why.
So pen testers don't have to worry?
About pen testers, I cannot say for sure. I don't have very much knowledge into pen testing, but my thought is, for at least for some years, it's like we are in a very beginning stage of AI. So from my past experience, we were using some tools, some tools like EDR and DLP in our environment, but those tools had a module for artificial intelligence, machine learning. They were not that powerful. So we need a lot of fine-tuning. Maybe Mashhood and Prashant can correct me if I'm wrong, but I think we are far away from that point where I don't know.
Where we just give it over to the
Yes.
machines?
Yes.
Yeah, all right, that's fair.
Well, I'm always philosophical before I'm granular or technical, to be honest with you. So my philosophy states that there will always be need for humans to use technology, not to be taken over by technology. There is always, technology is your best servant, but a bad master, as they call it. So it's important for you, and AI for me is a technology or a solution to solving problems. It is not augmenting or replacing human beings, because we are the ones who created them. So I'm not of the guys of the Skynets or the Terminators who think, that they will take over us, because we'll always have that kill switch which will kill them at some point in time. So maybe beyond my days, if I die, AI might take over, but at least in my days, it'll stay as it is. So with that said, I'm of the belief that the technology should augment you and your function to do it right and do it efficiently in an optimized fashion. So if I'm a cybersecurity expert, I want to do pen testing as an example, what Pooja took. I want to write an exploit code. Now, I don't have to go through 5 different websites or whatnot. In fact, Corey gave a talk on in his last slide. He mentioned that you could use ChatGPT now to look at your API security vulnerabilities, and right off the bat, because it can scour the internet to give you that instead of going through 500 different API endpoints. So you're using a technology to augment you, and in my opinion, that should always be the case with AI. Yes, you need a human check, to make sure that what you got is right, and we can go into things like hallucination or harmful bias and whatnot. But yeah, that's my opinion. I still don't think that I'll be replaced by a robot sometime in future. Thank you.
Gotcha.
So I agree. The technology it's a tool that we can use to give a leverage to ourselves, meaning it's a tool that if we can start using it today, it will help us do our job better, quicker, and faster. Whether it's AI, it's computing technology, or any other technology, we need to use it. The key here is to learn those new technologies and start using it. The other key is we need to remember that whatever technology or AI model that we are using today, they will become irrelevant tomorrow. So how many of you in the room remember MapQuest? Okay. And we forget about them. That was a part of our life, sometime back before the Google Maps, right? So we forget things. What is important is our ability to unlearn and relearn. And I will let this digest. Because whatever technology we are using today will become irrelevant tomorrow. So tomorrow we need to unlearn it and relearn it new way. And that unlearning and relearning cycle will happen much more faster than we have experienced before. This is the first generation that we will experience multiple industrial revolutions in our lifetime. So it is very important for us to unlearn and relearn the new way. Now, talking about whether AI can do pen testing. So some use cases for pen testing, yes, AI can help us do it better. Right? Like Prashant mentioned example from yesterday's talk that you can use ChatGPT to look at some of the APIs and some of the scripts. But there's still need for a human to validate whether that was the right use case for the situation. So there will always be a need for a human to overlook and give the oversight and provide the human context. Thank you.
Thanks.
Just a quick one, if I may,
Yeah,
just a very quick point, right? We always think technology and robotics would be optimizing fast and whatnot. Think for a second, human beings just don't have the good side of their life. They always have the bad side too. They're clever, they're disgusting, they're frustrating sometimes. There are emotions there. Can you ever imagine technology to be clever, cutting corners, or trying to do things where they are unethical in nature? So think about that. It's not about just the fastness and the optimization side, but it's also seeing how can you actually mimic a human being in all its aspects of being right and wrong, good and bad, beautiful and ugly. And not sure if technology could ever do that, but that's my point. Thank you.
That's the goal, right? I think we're like when we talk about generative AI, we're not there yet. We're dealing with bots or self-driving cars that do one thing very well, just one thing. Human beings are complex, like you said, right? We do many things. We touch, we see, we like the idea. I think we're still very much in the infancy of machines being able to even understand touch and smell. We don't even really understand how our nose works, right? So it's hard for us to replicate that. But there was something that Mashhood said. He talked about relearning and unlearning and relearning, right? And I think that for many of us in cybersecurity, that is familiar. Like, if you're in cyber, you're probably someone that likes to learn, right? You likes to find out about new things. So I guess for Pooja, as a student, what do you say to someone who is looking to get into cybersecurity in an era where AI is playing such a prominent role? And we know that what we're seeing now with ChatGPT isn't new, right? Like, ChatGPT's been around for a long time. It was just released to the public last November, but it's been there for a while. It's been in our products for a while. And so now that everything is at the forefront, what's the advice that you would give to persons looking to get into cybersecurity?
Thanks, Nickkisha. So, yeah, I have a lot of thoughts on this. First thing that I would like to say to all the newcomers in cybersecurity is have curiosity. There's so many things in cybersecurity, so you will always find something that you'll feel passionate about, especially right now when so many technologies are advancing very quickly, and they are merging together. So there's a lot of scope. So create some curiosity. And then about using generative AI, so always understand there are things which generative AI can do for you, but it has a lot of limitations too. So just giving an example, when I started preparing for a presentation on AI risks and control, I tried to use ChatGPT for some of my research, but it can never generate the ideas or it can never generate the kind of critical thinking, the ideas that you can have with critical thinking. So always, try to go through like a lot of resources. It will give you a deep understanding of the subject. And now we are in an era where we have a lot of open resources like LinkedIn. I really like it a lot these days because I get a lot of free resources. Whatever subject I want to check about, there is something about there on LinkedIn or some other open resources like YouTube or GitHub. There are so many. So learn it, and then again, we have an amazing community here in Edmonton and overall globally. So collaborate more and more with people. So just have curiosity and feed your curiosity. That's all I can say.
Thanks, Pooja. Now, I know that we're close to time, and I do want to get the audience involved. So we're going to forego some of the questions that we have and just open it up to the audience for a bit. Are there any questions that you have or comments? Yep. Do we have... Do you want to? I'll come. Okay.
Thank you. Yeah, so we've talked a little bit about quantum computing and AI. Now, if you take this to its logical conclusion and you combine the two, say we would take ChatGPT-4 and we would hook it up to a quantum computer. We would feed it all the data we have. We would give it this nice context. So ChatGPT works with like tokens, right, and how much context it can digest. So now that's pretty low. It can like digest 32,000 words, I think, at the most, and remember that context and give answers intelligent to that context. But now we have a quantum computer, so we can do like a million tokens context. What would that look like, do you think? How would it impact things?
Is there someone you'd like to tackle the question? Okay.
Well, that's a very scary question, actually. I didn't think about it. Like quantum computing marrying artificial intelligence, and you know, God is your savior. It will be definitely game-changing, I must say, right? Imagine for a second when you marry two big computing, like two big concepts, and you merge them together. It will be definitely game-changing. Now, what are those possibilities? I mean, it's open to your human mind. End of the day, quantum computing can bring you the fastness what you need, and ChatGPT, for that matter, as you said, you know, million tokens or more than that when you're trying to leverage natural language processing to figure it out. I mean, I would love to get that our end product go through a Turing test. I don't know if you know what a Turing test is, for those who probably know. A Turing test is basically go in a black box, you have a computer, and then you have a human being, and you start pointing questions to them, and they both answer you, and you can't figure out whether that's an actual human being or a computer answering you. And that's probably what Alan Turing said in 1950s, I imagine, saying, that's when I can say it's an actual artificial intelligence mimicking a real intelligence, because you cannot differentiate between the two. I would love to get that particular product or machine or solution, for that matter, go through a Turing test and still figure out, can that be a real human being, or is that still an artificial intelligence but on steroids? So that's my quick answer to that.
I just want to add one thing, a scenario. So we live in Alberta, and we understand why there's a need for a pipeline that can take oil from Alberta out, right? It's critical for us. It's not critical for the BC or the US or for some other different regions, right? If you ask this question to an AI or quantum computing, it will give you a logical answer that makes sense to it. But when it comes to human, we have our own bias. We have our own decision making. We have our own reasons, right? So somebody may say it's because of the environmental damage. Other people may say it's a cost or whatever. But at the end, you will have your logic that is true or false, right? But the human connectivity and how human perceive things, that will still continue to play the role in future. Thank you.
Thanks, Mashhood. Do you have time for one more?
I'll pick on Prashant for a moment because you knew that it was coming. We talk about quantum computing from the perspective of the here and now, and I think that we're in the age where we will start to see quantum computers from a centralized data center perspective, but we don't really have the physical transport to be able to support quantum computers. So when do you think that we might have that physical transport layer to be able to support quantum in the way that many of us in the room may be envisioning, which is applying a quantum computer concept to a traditional computer? Or do you think that we'll get there? I'm still not sure.
Thank you, Michelle. First of all, she is actually, we know each other quite well for a long time. She's one of my best buddies, and it's always great to have questions coming from her in various forums. To answer your question, it's a very relevant question on what the transport mechanism would be of these qubits we keep talking about. But I'll encourage you to Google or read the phenomenon called quantum teleportation. And beam me up, Scotty, for those who might have seen Star Wars, right? You go into a chamber and you basically get out and you teleport back into some other universe or some other place. And that's actually a reality. When you go back and read physics, you will see Albert Einstein and Erwin Schrödinger, they were the stalwarts of quantum mechanics. They did what's called an EPR paradox, the Einstein-Podolsky-Rosen paradox, which basically states in a very simple term, you have a particle which goes from point A on the other end of the universe, breaks out and goes to the other end of the universe, two parts of the particle. You change the attribute of its momentum on the other end of the universe to be an up. Its momentum will change down on the next end of the universe because the laws of physics of momentum cannot be falsified in the world of physics. What happened there? Spooky action. The speed of light cannot even measure it for millions and billions of years from one end to the other end of the universe. But it actually happens in a laboratory experiment. The particles react in near instantaneous manner. When you talk on one, the other happens. That's called quantum teleportation. There are experiments around it, and I imagine that would be used in the field of communicating these states out from one point to another in the world of quantum computers. So it may not be traditional wires. It could be literally the spooky action at a distance where you are influencing from one point to another. Thank you.
All right, I've lost my mind, but I think we have a couple minutes left. And I just wanted to ask each of the panelists if there was one thing that they wanted you to take away from today's session, what would that one thing be? Yeah. Be very scared? No.
Yeah, so on that, keep yourself open. Just don't be scared, be optimistic, be informed. So, stay updated.
I love the way Angie says it, right? Scared. But I'd say, be curious. You are a kid in a candy shop, be curious, and the world is open for you. So just learn.
And I'm gonna repeat what I said earlier. It's our ability to unlearn and relearn the new way. Thank you.
That's excellent. Thank you. Haima?